Hey guys, welcome back to the DIY water channel. Today we are going to be making a solar water disinfection system. So a solar water disinfection system is a portable water system that uses the sun's light, which has UV rays, to disinfect dirty water. The dirty water in this case contains microcontaminants such as bacteria and viruses, and the UV light coming from the sun is going to disinfect this water. Now for the materials. So the system, just like the solar water distillation system, really requires very less materials to make. So the first thing we're going to be needing is a cloth. So any sort of cloth, like I said, the cloth doesn't have to be special, it just has to be clean. You could get this cloth from anywhere. This one I got from my kitchen, it's a cleaning rag. So any cloth would work. Then you need a sieve. So such a sieve would work, it's perfect. It just has to be able to fit on top of a cap of a plastic bottle. So when you're pouring it, there is no wastage. So this small one would work well enough. Then our next material are plastic bottles. So you could use any sort of plastic bottle. The big ones like the 1.5 liter ones, small ones, 500 milliliters, any ones would work. You could even use these ones if you would like. They're just not the best for what we're going to be doing with the system. So these bottles are the best. Also, you would want to avoid any sort of bottle that has a coloring. Like this one, it has a green tint to it. This is not so good because the sun's light is not going to be able to effectively enter inside a green bottle like this. So it's best to take a transparent plastic bottle like this of any size. Then we need a paper and a marker. So this one is really optional. If you have a newspaper or anything, you could use that. This is just to test if our water is actually going to be good to use. And to get these materials is also very easy. All of these can be found at your house. The plastic bottles that you can see over here, you can find these at the local beach. If they're not at home, of course, they can be found at home very easily. You just have to look. Otherwise, you could buy the water bottles that you get inside these plastic bottles, drink the water, and then you have these plastic bottles. Of course, that would be unlikely. Otherwise, you're not going to be seeing the video on how to make water if you have water. So it's easier for you to find these bottles at the beach. The paper and marker, well, I've used paper and marker. You could use a newspaper or any sort of paper that has a large text on it. This can be found at home very easily. The cloth, like I said before, any sort of cloth would be good. It just has to be clean. The sieve as well, your kitchen is the best bet. You're going to find a sieve very easily. So that's all. Let's see the procedure now. Now the procedure. So the first thing you're going to need to do is take this sieve, then fold up this cloth, and then stuff it inside so that you have like a makeshift filter made out of the sieve and the cloth. So you can see here. Our next step is going to be to pour the water, whichever sample of water we have, through the sieve into the bottle. If the mouth of your bottle is really small like this one over here, what you could do is you could just pour it into a larger mouth first and then transfer this into the smaller mouth, which is of course easier. However, you must keep one thing in mind, and that is you cannot use any type of water. And to know which type of water you can use, we're going to be using this small tester. So using a marker, write your name on the piece of paper that you have. So I've written my name. Try to write it big so that you can see it once you write your name. So here, I've written my name here. So now what you're going to want to do is you're going to want to put up the water sample on top and to see if you can read it. If you can read it, then it's good. But if you cannot, then you cannot use this sample. So the best way to do it for such bottles is to make them lie down like this and see if you can read it. If you can, it's good. But the clearer it is, the more efficient your disinfection method is going to be. So like you can see over here, in the atmospherically condensed water, it's very easy to see the first 2 letters of my name. It's really easy. But over here in the house wastewater, it's barely visible as to what we're seeing. So from this we can conclude that this one is not very good for our disinfection process, but the atmospherically condensed water is very good. However, I'm going to be testing both and we're going to see the results afterwards. And after we finish verifying if the water is actually clean to drink, we then have to take this sample of water that we're going to be putting into the bottle and we have to go and keep it in the sun. So when you're keeping it, you want to make sure that the sun is hitting it directly and so that the water is actually going to be hit by the sun and it's not being covered by any shadows of any kind. Now for the testing. So we're going to be doing what we've always been doing. We have 6 samples of water over here. First one is house wastewater. The second one is atmospherically condensed water. The third one is rainwater. The fourth one is factory wastewater. The fifth one is seawater. And finally the last one is borewell water. So what we're going to be doing is we're going to be using 1 cup of each of these samples and we are going to be testing out our process with it. So I'm going to be doing 1 on screen and the remaining off screen to save time. So the one I'm going to be doing on screen is going to be this one, the rainwater. So now we can just move these ones since we're not going to be needing them. And now the rainwater. So we're going to carry out the process over here. We're going to pour in 1 cup of this rainwater into that, like this. There we go, 1 cup. First, we're going to be pouring it into the large jar over here like this, and then we are going to be transferring this over to the smaller jar. So now we want to just position it like this, hold it properly, place the cloth on top of it like this. So this system shouldn't be hard to use, it's easy. Really, we're using this filter first because we want to be sure that none of the physical contaminants inside of the water is being transferred into the disinfection process, because the disinfection process is not going to be taking out any of the contaminants, the visible contaminants of course. So now we have to carefully pour it inside like this. So you can see that it's been filtering out over here. Of course, there are no visible contaminants inside the original water, so there is not much over here as well. So it's going slowly. It's almost done. We finished what was in the cup, now it's just filtering. So what you can do after it finishes filtering, if there is a bit of water left over here, all you have to do is cover the top, of course, like this, how I'm taking it. Then you just have to squeeze like this, and whatever remaining water is there, it's going to come out. And the contaminants, of course, will stay inside because you closed it and they're going to be held back by the cloth. So there you go, that's it. And the first part is done. Now you can just pour out anything you want. And you can see that our gain is not much. So we're going to be pouring this into this one now. That's 1 cup. You want to be very careful about how you're doing it. You don't want to drop anything. So one thing you should not forget is that you should shake this water after you finish adding it inside. Like before you fill it up the whole way, fill it up halfway, shake it so that the air inside mixes up with the water, and then add the remaining water. This will make the system work better because the air particles will allow the UV rays to actually enter the water. So there we go, this is what we have, and now we're going to test if we can actually use this water. It's quite minimal, so we can just keep it like this and then see it. So as you can see, it's really easy to see whatever is over here. And so even if we move it around, we can see my name very clearly. And this is a success. We can use this water to disinfect. So now the next step is to, of course, take it upstairs and keep it in the sun. That's all we have to do. And before I forget, there are no modifications you can make to this system. This is because the system is already really simple and there's no need to modify it in any way. So guys, we're upstairs again. And you can see I've completely filled it up. So before I realized that much water that we had was very less, and this process wouldn't work well. So I've added more of the rainwater and shaken it, of course, so all the water and the air mixed up. So now we're upstairs and we're just gonna leave it in the sun. So to leave it, you could of course just leave it like this, lying down on its back, or you could keep it up straight up like this, anyway. But the best way, in my opinion, would be something like a propping up thing. So this, I've just found it up on my terrace. It's just a cover of a big container, and all I'm going to do is keep it like this. And so what's going to happen is going to allow the sun to hit it more easily, because when it's lying down, the sun is not actually hitting every part. And when it's standing, it's of course the cap is blocking some parts. But when it's like this, everywhere is being hit. And plus, this container will even reflect some of that heat back, so that the back part is also going to be heated up. So the optimal time to leave this would be about 5 to 6 hours. And I'm going to come back tomorrow and see how it's doing. So night, of course, it's not going to disinfect, but like by tomorrow afternoon, it should disinfect somehow. So I'm going to be bringing the other samples as well. I'm going to be filtering them out, and then I'm going to be filling them up, and I'm going to keep them over here. And so by tomorrow afternoon, they should be ready. And while we wait for this system to finish its process, let us discuss some of the advantages and disadvantages of it. So the first advantage is it is very cheap. You really need to just get plastic bottles, which you can find at a local beach or at home very easily. You really don't need to pay for anything. It is also really effective at killing a lot of bacteria and viruses. It is also really eco-friendly because we're using the sun's energy to be able to disinfect the system. And it is also certified because the UNESCO has used this system to disinfect dirty water in many countries all around the world. It also doesn't have any chemicals such as chlorine that is otherwise used for disinfecting water. It also does not use any fuel, which means no carbon dioxide emissions. It can also be productive because many liters of water can be produced if you set up multiple units of this. However, there are many disadvantages as well. This system will not work if it's rainy or cloudy outside. It depends on the climate a lot. It also, this is a must, it requires visually clean water. Because if the water looks dirty, then we cannot filter it of any contaminants, and so even after disinfection, it's not going to be safe to drink. It also takes very long. This is one of the longest potable water processes out there. The average time it takes to finish disinfecting on a really sunny day is about 6 to 7 hours. It increases on cloudy days to about 12 to 16 hours. Some advice during this procedure is mix the water halfway through so that the UV light can enter the water easily. Also, if you can, color the container black because a black container absorbs more heat and thus boosts the speed of the process. Also, set up multiple systems like this so that you can get more gain in one day. Because the sun's light is unlimited, and if you set up multiple systems, you're going to get more water eventually than if you just set up one system. That's all from here. Let's go and check out how our systems are doing. Hey guys, it's been about 4 to 5 hours.
Sun is still out, but it's evening time and it's going to be going down. So you can see over here, these are the 6 containers. So I have used 2 small 500-liter ones, these 2. However, I have incorporated other containers as well. Like you can see, this one, this is not a water bottle. I've done this to show you that you can use almost any container that's transparent and this will work. So I'm going to be leaving this for another hour or so, and then I'm going to be coming back because it's been about 5 to 6 hours and I'm thinking it's going to finish disinfecting. Of course, there are no cues that can tell us whether disinfection is completed or no, since this is a micro-contaminant level and we cannot actually know. So in about 1 hour, I'm going to take it downstairs.
Hey guys, we're back, but it's not the same day anymore. We're now in tomorrow, and this is because I decided, just so that we're safe, let's leave it till tomorrow. And so now it's the evening time. I left one whole day, and now I think we're ready to be able to see if they're disinfected or no. So you can see that each one has their disinfected counterparts over here. And now, as always, we're going to be doing our sight and smell test. I'm not going to be tasting these samples because of safety reasons, and also because the filtration process was not actually the best, and so I do not want to be taking in any contaminants of any kind. And so I'm going to be limiting the initial test only to the sight and smell. So let's start off with the first test, which is the sight test. And we're going to be doing the house wastewater first. So the house wastewater, already comparing both of them, you can see that they're very different, that one is lighter than the other. In fact, I would say that the disinfected one looks more like coconut oil than anything else. It's really light, but it's still murky. So, yes. Next, the atmospherically condensed water. This one looks like water that I drink. I can't see any contaminant inside, really. It passed almost all the visual tests, and so I think that this is like visually clear to drink. The factory municipal water. This one, it still has a slight tint of oil, the one that we find inside the factories. But I would say comparatively, it's way less than before, and visually, it's cleaner. The rainwater. The rainwater doesn't look very visually clean. It still has a lot of the microbes, particles inside, and I don't think that this has passed the visual test. It's really dirty. The water is clear, but there are a lot of miniature particles inside. The seawater is also like the atmospherically condensed water. You can't actually see anything, it's quite clear. I can't see any of the microbes inside, and none of the particles are visible. Finally, the borewell water, also the same, quite clean, because all of the borewell water's particles had settled to the bottom, and because of that, none of the initial orange stuff came into the water bottle even before disinfection. So what I would say visually is that the house wastewater has not passed the visual test, and neither has the rainwater. However, right now I would rank the atmospherically condensed water, borewell water, and seawater as the cleanest looking. The factory municipal water, I would rank it like 4th in the dirtiest, so 2nd in the cleanest. Let's move on to the smell test. So I'm going to be taking each of the samples and smelling them and telling you how they smell. So first, for the house wastewater. God, this one does not smell good at all. It smells like wastewater. So, as I was saying before, this has completely failed our test, the house wastewater. Solar disinfection is not good for this method, as I have said previously, because you cannot disinfect water that is so contaminated. Water that's clearer, you can. This one cannot. So that is why it is important to keep in mind that don't use water that you cannot see through. Next, for the atmospherically condensed water. It has no smell. Just to double check, but no, it has no smell. It smells like, well, water, and water has no smell. The factory municipal water, yes, it still does have the oil smell, the diesel and petrol smell. So I would say it has not completely passed the test. However, it is quite less than before. Before, if you get the scent, it's really strong, concentrated petrol. This one is not so much. It looks like it's diluted into the water. Next, for the rainwater. Surprisingly, the rainwater doesn't have any smell. It looks metallic, but the metallic smell is not so concentrated. Because I know that it is rainwater, I can get this metallic scent, but otherwise, I would say it has passed the scent test at least. The seawater smells, well, it doesn't have a salty, sulfuric smell. It's neutral, I would say. I would say it's not like water, but then I would not say it's not like seawater. Finally, the borewell water. This is, according to me, the cleanest looking and cleanest smelling. I actually cannot get any smell from this, really. No smell. Looks refreshing, but I'm not drinking it because I do not want to risk it. So this is the initial test, and as I had said before, I can conclude that the atmospherically condensed water, the seawater and the borewell water, those are the cleanest after solar disinfection. The remaining ones still rank low and according to me have not passed the test. However, since I'm not a scientist, I cannot conclude that without any evidence, and so I am going to be sending these over to a lab to be tested thoroughly so that we can really understand if solar disinfection is a good method to clean your water or is it not. Until next time, see you.
But before you go, let us do a small recap on what we have learned today. Today, we have built a solar water disinfection system. This system disinfects dirty water of any bacteria or viruses. This system uses the sun's light and ultraviolet rays to disinfect the water. The materials used to build this system are a plastic bottle, a wide-mounted plastic container, a cloth, and finally a sieve. The procedure to build this system is quite simplistic. First, filter out the dirty water through layers of cloth and sieve. Collect this dirty water in a wider mounted plastic container. Transfer the dirty water into the plastic bottle and keep the plastic bottle in a sunlit area. Leave the bottle over there for 6 to 10 hours on a sunny day or 12 to 16 hours on a cloudy day. Some things to keep in mind about this system is that it is quite cheap, it is effective at killing most bacteria and parasites, and viruses as well. This system is a certified eco-friendly system that has been used by the UNESCO in numerous countries across the world. This system does not require chemicals to work, neither does it require any fuel. This is why there are no carbon dioxide emissions from this system. This system can also be productive if many systems are made and put on the same day in the same place. This is in fact recommended to be able to boost the performance of this system. Setting up multiple systems such as this on the same day means you have more gain in terms of water. It is also recommended to color the container black since this increases the rate at which the system disinfects the water. There are also a few disadvantages. This system depends highly on the climate and it needs sunny weather to actually work. This system also requires visually clean water, otherwise this system will not work. And it also takes a lot of time for the system to complete. One more thing to keep in mind is that this system does not kill all bacteria or viruses. Bacteria such as Cryptosporidium will not die with this system, and no physical contaminants can be removed from the water to this system. This system is only effective at killing bacteria and viruses. Thank you and see you next time.